Bismillahirrahmanirrahim. This is question number 1 of exercise 4.2. We have 6 parts. Okay, for the first part, it is okay. First of all, let's write a formula over here. Oops. For arithmetic sequence, you have to keep it in mind that these formulas are only for arithmetic sequence. Okay, an, which means the nth term, is equals to a1 plus n minus 1 into d. Okay, an equals a1 plus n minus 1 into d. So we have to use this formula in all of these questions. What do we have to find? Find the first 4 terms of each arithmetic sequence. So this means that we have to find a1, a2, a3, a4. We are given with a1 in all of these parts, so we have to find a2, a3, and a4. So for a2, okay, question number 1, part 1, which is a1 equals 4 and d equals 3. Let's solve it. We have to find a2. a2 is equals to a1 plus n minus 1 into d, a1 plus n minus 1 into d. What is n over here? N is 2. So a2 equals a1, which is 4, plus n is 2 minus 1 into d is 3. So 4 plus 1 into 3, 4 plus 3 equals 7. Now a3 equals a1 plus n minus 1 into d will remain same. It's the formula. Here n is 3 because it is a third term. So now a1 is 4 plus 3 minus 1 into d is 3. It is equals to 4 plus 2 into 3, which is equals to 2 3s are 6 plus 4 is 10. Now we have to find a4 is equals to a1 plus n minus 1 into d. N is 4 over here, so n equals 4. Then we have it is equals to a1 is 4 plus n is 4 minus 1 into d is 3. It is equals to 4 plus 3 into 3, which is equals to 3 3s are 9 plus 4 gives us 13. So here is our result, but we can also do it without using this arithmetic sequence formula for the nth term. We can do it other than that too. Let's do it in the second part, okay? In the way I'm telling. Second part is a1 equals 7 and d equals 5. Okay. So we have to find a2. a2 equals a1 plus d. What is d? Let's imagine this is an arithmetic sequence which has the terms a1, a2, a3, a4, and so on. Okay. So the difference between a2 and a1, which is a2 minus a1, difference between a3 and a2 would be a3 minus a2, right? Difference between a4 and a3 will be a4 minus a3, and so on. For every term, the difference between two terms will be equal to the second term minus the first one. So we have done it over here. Now all of these are supposed to be equal, and when they're equal, we consider it equal to a difference. So this means that when a1 is added with this difference, we get a2. Then when again this difference is added, we get a3. Matlab a1 plus difference equals a2. Similarly, a2 plus difference equals a3. a3 plus difference equals a4. So this means that all of these terms have the same difference in between the consecutive two terms. So the difference is common. We have same difference all around this arithmetic sequence. So we have to keep this concept in mind. Now while using this concept, just imagine what will be the value of a3 minus a1. Okay, let's do it. A3 minus A1 will be equal to A3 minus A2 plus A2 minus A1, right? Because this whole difference will be equal to this difference plus this difference right now. So this difference is equal to D, and this difference is also equals to D. So when two D's are together, we name it as 2D. So the difference between this and this will be equal to 2D. 2 times this difference between any single one of them, okay? So this is D, and this entire difference is 2D. This entire difference will be 3D, okay? So A2 equals A1 plus D. Now we are going to solve it. A2 equals A1 plus D. So A2 equals A1 is, where is A1 kept? It's 7 plus D is 5. So 7 plus 5 gives us 12. Now A3 equals A2 plus D, which is equals to A2 is, A2 is 12 plus D is 5 equals 17. Then A4 equals A3 plus D, which is equals to, um, yes, this is A3. A3 is 17 plus 5, which is equals to 22. Okay, let us find okay, there is A1. Now let's find A2, A3, A4, and so on, okay, using this formula. For A2, n will be equal to 2, right? We have to keep this in mind. Okay, so n is 2, A2 equals A1 plus n is 2 minus 1 into D, which is equals to A1 plus D. So we can also get this formula that we have written over here using that diagram, using that diagrammatic scheme. We can also prove it using this formula. So this and this are same. Similarly, if we find A3, A3 equals A1 plus n is going to be 3 minus 1 into D, which is equals to A1 plus 2D. Now A4 is equals to A1 plus 4 minus 1 into D, which is equals to A1 plus 3D. Now as we see, all of these, A2 equals A1 plus D, A3 equals A1 plus 2D, A4 equals A1 plus 3D, all of them have A1 plus the number written over here minus 1 into D. So 4 minus 1, 3D. So what will be A5? A5 equals A1 plus 4D. Okay. What will be A10 is equals to A1 plus 9D. What will be A100? It will be equal to A1 plus 99D. So we can understand a lot of concepts from this one. We can derive it all. So just keep it in mind. We are going to use it in further questions, okay? Now let's move towards the third part, which is A1 equals 16 and D equals minus 2. This method was extremely lengthy and this was a very small method. So we are going to use this one for the rest of our questions. Okay. A2 equals A1 plus D, which is equals to 16 minus 2, which is 14. Okay, here we used A2 plus D, A3 plus D. Now let's use A3 equals A1 plus 2D, this formula for the rest of the values as well, okay? So A1 plus 2D, A1 is 16 plus 2 into D is minus 2. So it becomes A3 equals 16 minus 4, which is equals to 12. Then we have A4 equals A1 plus 3D, which is equals to A1 is 16 plus 3 into D is minus 2. Now it is equals to 16 minus 6, which is equals to 10. So it's done. Now let's move towards part number 4, which we are going to do over here. A1 equals 38 and D equals minus 4. Okay. We are again going to use this method. Then for this part, we are going to use this method. And for this part, we are going to use this method so that we repeat all the methods we have used. Okay. So we have A2 equals A1 plus n minus 1 into D. Value of n over here is 2. So it is equals to A1 is 38 plus n is 2 minus 1, which is 1. Okay, so let's write it. 2 minus 1 into D is minus 4. So it is equals to 38 minus 4, which is equals to 34. Then we have A3 equals to A1 plus n minus 1 into D. We have the 3 as the value of n. It is equals to A1 is 38 plus n is 3 minus 1 into D is minus 4. It is equals to 38 plus 2 into minus 4, which is equals to 38 minus 8, which is 30. Now A4 equals to A1 plus n minus 1 into D. N is equals to 4, so it is equals to A1 plus 4 minus 1 into D is minus 4. A1, sorry, is 38. Let's erase it and write 38 instead. Okay, 38 plus 3 into minus 4, which is equals to, 30, 38 minus 12, which is equals to, is it going to be 12? Yeah, it is equals to 26. Okay, we are done with the fourth part. Now we are going to do the fifth part. A1 equals 3 by 4 and D equals 1 by 4. Okay, so we are going to use this method over here. So let's write it. A2 equals A1 plus D. So we have A1 is 3 by 4 plus D is 1 by 4. We are going to take 4 as LCM, 3 plus 1, which is equals to 4 by 4, which is equals to 1. Now A3 equals A2 plus D, which is equals to A2 is 1 plus D is 1 by 4. Again, 4 is taken LCM, 4 plus 1 is equals to 5 by 4. Then we have A4 equals to A3 plus D, which is equals to 5 by 4. A3 is 5 by 4 and D is 1 by 4. So 4 is taken as LCM, 5 plus 1, which is equals to 6 by 4, which is equals to 3 by 2. Now we are going to do the sixth part, which is the last part of this question. Okay, sixth part is A1 equals 3 by 8 and D equals 5 by 8. Okay, A1 equals 3 by 8 and D equals 5 by 8. And we are going to use this method over here. So let's do it. Yeah. A2 equals A1 plus D, which is equals to A1 is 3 by 8 plus D is 5 by 8, which is equals to 3 plus 5 whole divided by LCM, which is 8. So 3 plus 5 is 8 by 8, which is equals to 1. Now A3 equals to A1 plus 2D, which is equals to A1 is 3 by 8 plus 2 into D is 5 by 8. We are not going to cancel this 2 and 8 because we have to take 8 as LCM. So let's take LCM. 3 plus 5 twos are 10, which is equals to 13 by 8. Now we have A4 is equals to A1 plus 3D, which is equals to 3 by 8 plus 3 into 5 by 8, which is equals to, taking 8 as LCM, then 3 plus 3 fives are 15, which is equals to 18 by 8, which is equals to 9 by 4. So we are done with the sixth part. Thank you so much.